Good morning to everybody. I am Mattia INTIGNANO, a second-year PhD student at the Department of Civil Construction and Environmental Engineering of the University of Naples Federico II. My supervisors are Professors Gianluca dell'Acqua and Salvatore Biancardo. Today I will speak to you about my research and show you what I'm actually working on. There is a methodological approach that exploits visual programming language for the automatic production of a stone-paved roads building information model. The presentation is structured in 3 sections. In the first, I will introduce the research project and its background. In the second, the focus will be on the research aim and the milestones that I reached till now. In the third and last section, I will describe the methodology and I will discuss its future development. My research project lays in the wake of the objectives of the PON Programma Operativo Nazionale 2014-2020, PhD for Innovation. The main theme of my research is the digitalization of linear infrastructures through building information modeling methodological approach, which allows for the management of the information flow that characterizes the useful life of an asset, starting from planning through design, construction, maintenance, and ending with the decommissioning of the asset. Infrastructural road BIM involves the multidimensional modeling of the road, based on tools such as softwares for geometric modeling, dedicated programming languages, and cloud platforms for sharing models with all the figures involved in the project. So, the first of the pivotal topics I will talk to you about today is BIM, with a specific focus on linear infrastructures. Indeed, BIM for vertical structure, thus for architecture, for example, is more developed, and it is based on object-oriented modeling, while BIM for horizontal structures, as roads, has still to express its full potential, and it is based on procedural modeling. It means that the logic behind the modeling is composed by subsequent phases based on hard-coded dependencies relationship. In my early research, I dealt with geometric and semantic modeling that is related to the information contained in the model through procedural modeling enhanced by scripting. Being always fascinated from the possibility of turning manual operation into automatic, but not having an informatic background necessary to coding proficiently, I studied the possibilities offered by visual programming language for the design of algorithms within BIM-based tools. As an example of a VPLE graph, in this slide is shown the algorithm for the implementation of a cost-benefit analysis within the BIM project of high-speed train line Napoli-Bari. Graphical nodes are composed by one or more functions made of one or more lines of code, and links establish their input-output relationships. As far as the state of the art of my research is concerned, I mainly have been focusing on the uses of VPL for parametric modeling and generative modeling. Indeed, the works of my tutor, Professor Biancardo, had me dealing with the central concept of parametric modeling in BIM and the integration of VPL. The literature review work from Collau, published in 2021, made me deepen the theme of VPL and its applications in road infrastructures. And finally, the work from Tang was the first I read about that tried to model at least part of an infrastructure by means of VPL. BIM is relatively young. A multitude of tools were developed in these years, often not very coordinated and with interoperability issues. This led to lack of qualified personnel and to the need for companies to adapt quickly and invest resources for training and updating, often for law enforcement and without embracing the full potential of the methodology. Indeed, BIM today is intended as the ensemble of design, modeling, interoperability, and coordination, but as separated phases. Instead, to fully exploit BIM advantages, it would be necessary to implement them in a synergic way, so to put the design at the center of the BIM process. To cover this gap, the research should focus on the development of smarter and more user-friendly BIM workflows, since working in BIM should not be seen as a regulatory obligation, but as a methodology that has many advantages, including more accurate design, error reduction, time and cost savings, better coordination, interference detection, and accessibility of data over time. So, the aim of my research is to automating procedural modeling processes using VPL integrating both geometric and semantic modeling to achieve high-quality road building information models. To do so, I have defined some milestones as the development of VPL algorithms to implement geometric modeling and semantic modeling. The automation of modeling for geometry and semantics can be achieved for specific operations limited to specific aspects of the BIM process. So, the third milestone deals with the development of algorithms in VPL for the full automatic modeling. Final milestone will be the development of algorithms capable of automatically model and design in BIM, empowered with the many technological cutting-edge tools available as artificial intelligence language services. So I developed a first algorithm capable to create the geometric model of a stone-paved road composed of 3 layers and on which flagstones are deployed corresponding to a precise pattern. The algorithm receives in input some geometric data, and at the same time it imports the geometry of the road 3D axis already modeled in the main interface of the BIM authoring software SIIV 3D from Autodesk, one of the leaders in road and railway BIM. A second algorithm is capable to add information to the geometric model by importing its solid objects and data from an Excel file. The only data that the user must give in input are the names of the AutoCAD layers where the solid objects are stored. The third algorithm has the task of developing automatically the geometry of the 3D axis of the road by using as input the data organized in an Excel file. All these 3 algorithms are semi-automatic since they need the user to practically insert some inputs. The methodology I developed for the BIM of stone-paved roads, but which is of general validity, tends to integrate the algorithms I've shown you before and improve their automation. It consists in 4 phases. The first one for the dataset definition by preparing a spreadsheet with broad design data about topography, road geometry design, the pavement structure, and the maintenance plan. Phase 2 consisting in the geometric modeling of the asset by the use of Dynamo, a VPL environment extension of BIM authoring software SIIV 3D. Data of topography and road geometry design are used to model the digital terrain model, the horizontal alignment, the vertical profile, and the corridor baseline that corresponds to the road 3D axis, and it is used as an extrusion path for the cross-section, which is modeled starting from the pavement structure data. Phase 3 consists in 6D modeling, that is BIM dimension for maintenance and operation phase according to Italian standards UNI 11337 by means of the maintenance plan. Phase 4 consists in the export in EFC 4x3 format, realizing what is defined as semantic enhancement, when EFC is integrated with the information from external sources, as in this case. The algorithm runs in few seconds, completing modeling tasks that can take hours or days depending on the user's skills. Furthermore, the quality of the model is very high, considering that the scientific literature and engineering practice concerning BIM modeling of road pavements made of modular stone elements is very scarce, if not existent. Here it is, a short video showing a first part of my algorithm running. In few seconds, it turns an empty project into a topography with a road alignment. Here it is, the second part, turning the alignment that we produced previously into a 3D corridor. The algorithm runs for approximately 5 seconds, while this operation would take a couple of hours for an expert user. And you can see all the solid produced and all the modular elements. Currently, I'm working on a further expansion of this methodology that would consist in a 5th phase of semantic enrichment by the use of the ontologies for semantic modeling. Indeed, by turning the EFC into EFC OWL, there is a format to turn EFC into ontology web language readable file, it is then possible to perform queries by using Sparkle language, inferring new information. This is the definition of semantic enrichment. It is my intention to explore the possibilities offered from AI to perform these last operations, and maybe showing next year my results. I've just concluded, so thank you for your attention.